Hi, Math 17 students. This is Miss Griffith going over Chapter 7.1. This is going to be an introduction to hypothesis testing. All right. What you're going to learn today is how to state a null hypothesis and an alternative hypothesis. We abbreviate the null hypothesis as H sub 0 and the alternative hypothesis as H sub A. You're going to know how to identify type 1 and type 2 errors and interpret the level of significance. You'll learn how to know when to use a one-tailed or a two-tailed test. You will be looking at the alternative hypothesis. And then finally, you will know how to make and interpret a decision based on the results of a statistical test. This will make more sense in a few minutes. But if the p-value is less than alpha, we reject the null. And then if p-value is greater than alpha, you fail to reject the null. We only have two decisions we can make. All right, some definitions here. A significance test is a formal procedure for comparing an observed data with a claim, also called a hypothesis, and we want to know if it's true or not. The claim is a statement about a parameter. In this class, we're only going to be using proportion and mean. In other statistical classes, you might be using the standard deviation or variance. We express the results of a significance test in terms of a probability. You already know how to do that. You know how to go from a z-score to an area or a t-score to an area. We're looking for that area in order to compare it to alpha, which is our level of significance. Here's an example, all right. Somebody, I don't know who, says I can make 80% of my basketball free throws. To test my claim, you ask me to shoot 20 free throws. But that day, the person only makes 8. And we say, well, someone who makes 80% of their free throws would never only make 8 out of 20. But the person says, well, I'm having a bad day, or I'm injured, or the ball is dead, or the hoop is bent. Well, these might all be possibilities, but let's actually see how likely that it is that you genuinely make 80%, but only shoot 8 of 20 on this one trial run. Well, to do that, we could use binomial distribution, where n is 20. The probability of actually making the free throws is 0.8, and we want to know that he makes exactly 8, all right? Well, if we did plug that into our calculator, you would get 0.0001. Well, that's a very small chance that you would only make 8 out of 20 free throws if really you made 80% of your free throws. So this is the basics of hypothesis testing. An outcome that would rarely happen, all right, well, this would rarely happen if a claim were true, is good evidence that the claim is not true. So after doing this calculation, it doesn't appear that this person genuinely makes 80% of his free throws or her free throws. So we can essentially disprove that claim, all right? So there are two explanations of the fact that the basketball player only made 8 out of 20 of the free throws when he or she said that they actually make 80%, okay? Well, maybe the player's claim is correct, that the probability is 0.8, but by bad luck, a very unlikely outcome has occurred. Remember, we just calculated the outcome as this. Or the second explanation is the population proportion is not 0.80. So the sample result is not an unlikely outcome. Maybe this person just wanted to brag, right, and say they make 80% of their free throws, when in fact that is a wrong claim. Again, The basic idea of these statistical tests is an outcome that would rarely happen if a claim were true is good evidence that the claim is not true. And that's what we computed here. This is very unlikely that this would happen if the claim were true. So we're going to say that the claim is probably not true. All right, how do we set up a hypothesis test? All right, well, you need the null hypothesis and you need the alternative hypothesis, and they go in that order always. All right, well, the claim we weigh evidence against is a statistical test called the null. Often the null hypothesis is a statement of no difference. Okay, well, when you use the null when you write the null hypothesis, you are going to have either this less than or equal sign, this equal sign, or this greater or equal sign, no matter what. And then you're going to write the alternative hypothesis. This is the claim about the population that we are trying to find evidence for, okay? And that's called the alternative hypothesis. You do not want an equal sign ever when you're writing the alternative hypothesis. The alternative hypothesis will either be greater than, not equal to, or less than. And these are all connected, okay? Well, if the null hypothesis is less than or equal, you will automatically know that the alternative is greater. These are opposite signs. If the null hypothesis is equal to, you will automatically know that the alternative has to be not equal to. And if the null hypothesis is greater than or equal to, well, the opposite of that is less than. So these will always go together. In our example, we were talking about a proportion. So we write the proportion is equal to 0.80. Well, the alternative would be that the proportion is not equal to 0.80. You always write the null first, followed by the alternative, and you will always have some sort of population parameter here. In this case, it was proportion. We're only going to be working with proportion and means for this chapter. So let's do a few examples here. The directions ask us to state the parameter of interest. Okay, so are we looking for a proportion or a mean in this class? And state the hypotheses for the significance test. All right, let's look at number 1. A school publicizes that the proportion of its students who are involved in at least one extracurricular activity is 61%. But if we write that in a proportion, we write 0.61. So it looks like they're stating that it is, so that'd be equal to 0.61. Well, why did I put the equal to here? Well, remember that the null has to have one of these signs. Well, now that we have one of the hypotheses, we can actually just do the next one. So it's going to always be the same parameter. We're using proportion or mean, and I have to do the opposite sign, okay? It's going to be 0.61. Number 2, a car dealership announces that the mean time for an oil change is less than 15 minutes. And we're talking about the mean. So we're going to have mu. I know we're going to have mu for both of these. And they say is less than. Well, if I look at these signs up here, I know that less than goes with the alternative hypothesis. So I'm going to say less than 15 minutes here. Okay, and now I'll be able to fill in the null hypothesis. Well, what is the opposite of less than? It's greater or equal to. So this is going to be mu is greater or equal to 15 minutes. Okay, third example. A company advertises that the mean, okay, we're looking at mean, so we know we're going to write mean on both of these. Mean life of its furnaces is more than 18 years. More than. That's going to be a greater than sign. We know that that goes with the alternative hypothesis. So I'm going to do mu is greater than 18. Well, now we just have to figure out our null, which is always completely opposite of this. So this is greater than. Well, what's opposite of greater than? Less than or equal to 18. All right, so this is how we write our hypotheses. Always write the null first, followed by the alternative. And then just remember that the null has an equal to sign and the alternative does not. All right. Well, how do we decide if we can accept or reject a claim? We have to find something called a p-value. You already know what that is. That is simply going from a z-test to the probability or a t-test to a probability. So I'm going to have you read through this slide. All right. We can draw two conclusions after calculating our p-value. All right, if we have a small p-value, we're going to reject the null. All right, how small, we'll get to that. If you have a large p-value, you are going to fail to reject the null. So you do have to know both of these. A small p-value, we reject the null. That's one of the conclusions that we can make. And a large p-value, we fail to reject the null. Those are our two conclusions: reject the null or fail to reject the null. Okay, well, how small is small, right? Well, when is it small enough that we know we're going to reject the null? Well, we're going to compare it to the significance level. All right, so say we want to be 95% significant. Well, guess what? Alpha then is going to be 0.05. It's essentially the complement of how significant we want to be. So if our test asks us to be 95% significant, alpha is going to be 0.05, all right? Well, after you find your probability or your p-value, that's what you're going to compare it to decide whether you're going to reject the null or fail to reject the null. So if our p-value is less than alpha, and they have to give you alpha, okay? If p-value is less than alpha, we reject the null. Well, what does this mean? There is convincing evidence in favor of the alternative. So this is one of our options. Our other only option is if p-value is greater than alpha, they give alpha to you, we are going to fail to reject the null. So there is convincing evidence for the null. And this will make more sense too. This is today is just an introduction of hypotheses testing. We will in 7.2 actually conduct these tests. All right, we have type 1 and type 2 errors. Well, sometimes we are wrong when we are making these conclusions, okay? Maybe that basketball player actually does make 80% of his free throws, and we are saying that he doesn't, okay? Well, let's see what type of error that would be. If we reject the null when the null is true, we have committed a type 1 error. And that's what we did in our basketball example. We rejected that he makes 80% of his free throws. If he actually did, that would be a type 1 error. So, and then a type 2 error is if we fail to reject the null when the alternative is true. So notice this is pretty easy because we only have two options, two conclusions we make. We either reject the null or we fail to reject the null, okay? So again, if we reject the null, but it was actually true, we say that's a type 1 error. If we fail to reject the null when the alternative is true, we say it's a type 2 error.